start counting.
Okay.
Okay, we're going to go on and check your work and see if you got these correct. I know that I haven't given you a lot of time, but, and I hope my answers are correct. Because I did this in a hurry. That's not good. Do I have anything wrong? Oh, no, mine's wrong. Okay. Yeah. Yeah. I had an extra one that didn't print out. Good. All right. So are there any questions here? This is an extra. It was supposed to show up because I had a paper for you, but it didn't. Yes, ma'am?
On the square pyramid,
Square pyramid. Triangular square pyramid. Yes, ma'am?
vertices are 5. 1, 2, 3, 4, 5. But my edges, I'm getting 8.
Okay. I didn't have these in front of me when I did it, and that would certainly be right. There's 4, 5, 6, 7, 8. Yeah.
Okay. I just wanted to make sure.
That's what I'm saying. Take a look at mine. Make sure I have them, and I didn't. No. I'll have to edit it later. Could be, like I said. This is what I based it off of. And I was supposed to get that for you and couldn't. Okay, so these were the figures that I was using and wasn't able to print out. Alright, you have your chart. Patterns. What kind of patterns do you see from the numbers you have? Yes, sir?
Prisms, vertices are 2/3 the edges.
Ooh, interesting. Vertices are 2/3 the edges. Is that true for all of them?
In prisms. Prisms.
No, wait, say that one more time.
Yeah.
In prisms, the number of vertices is equal to 2/3 the number of edges.
Is that true for all of them?
You can say it, Doug.
Should be. Okay, that's interesting. What else? Some are the same.
In pyramids, your faces and your vertices are the same.
In all pyramids, do you think? Probably.
You mean your vertices and your edges are the same?
No,
Faces
faces.
and,
Faces and vertices.
okay.
No, wait a minute. No, yeah, vertices and faces. Is that what I said?
Yes.
Yes.
And that's right. Okay. Now, I want you to do something, I want you to look at these and find the number 2. In other words, and we're going quickly, guys, understand that, please. You may need to take the faces and the vertices and add them, and then subtract in some order, till it always becomes 2.
Wait, say that one more time, please.
You're going to take the attributes of like the cube, and you're going to find the number 2. So you're going to need to add and or subtract until you all, and same things until you find the number 2.
Yeah, you're adding faces and edges.
Take the face and together, try to put it.
Yay! Remember what you did and check it on all of them and make sure it does the same thing. They all need to follow the same pattern
On every single shape?
on every single shape. It should follow the pattern once you find it.
This is where I was telling you that brain doesn't pattern, it doesn't matter how fast you write.
Does that work every time? Okay.
The ability to recognize patterns is a horrible
Yes.
thing.
Yes. All 3 numbers every time, all 3 attributes.
The idea of
Yes.
being savant, somebody who is not smart but can do incredibly quick computation and things like that. So the ability to develop patterns is no indication. It's like kids who are autistic.
Well, she wrote the thing. Well, really, it was just like a vertical plus the faces, minus the edges,
So you said vertices.
Try that before you're ready.
It's a cube. I remember just trying similar.
Alright. Hopefully, we've seen a lot of really good stuff here. We have an extra column that we get to use. And you should have gotten this formula, or something, a derivative of this. We call this Euler's formula for platonic solids, or polygonal solids. Euler's formula. Anytime I take the vertices plus the faces minus the edges, I should get 2. I've done this in 6th grade. And we're going to put this in the last column. Remember we skipped a column? This is why. We're going to go back and put Euler's formula in. Oh, now we're not there. Sorry. Okay, so we'll just remember to put that in your last column. And we've opened our boxes. Any questions? All right.
If, I do have one quick
Sure.
teacher question. So my formula was different than that one, because mine was vertices minus the difference of the edges minus the faces.
And you
It
still got two.
Still works, right. So what if you have a kid that does that?
If I had time, we would have put them all up and checked.
Okay,
We don't have time.
yeah, that's fine.
I've been told to move it. Because addition, subtraction,
Right,
you can move things around.
right, okay.
Sometimes. Okay. So, we've sorted the box. Are we done? Everybody ready to go on? Okay, inside your shapes, you're going to find a plastic piece. Let's take the cube. We started with the cube all along. Let's continue with the cube. Open it up. Take out your piece, please. And this is my classroom. You'll be hearing this all the time. Yeah. It gets neater. I just hope we get the chance to get to the end. Okay. Line it out. Anybody know what this is called?
A net.
A net. How is this a net?
I don't know why it's called a net, but that's just what I've heard it called.
I think it's because
I don't know
you
why.
can, I don't know,
what it is.
you put it back together and what I relate this to is it's the skin.
Okay, yeah.
It is the skin of
The box.
the box.
Cube.
If I were to cut it out, this is how I would make it. This is the only shape that makes this. Is this the only net that I can have that will make this?
No.
Okay,
Could we define this like a two-dimensional?
we're going to. We certainly are. I wanted to show this first. This was going to be something that I'd hoped we would have time to do. And I have a paper for everybody, if you want. There's a whole bunch of nets. Which one of these makes up, or which of these makes up a cube? And I can tell you now, out of the whole page, there's 12 of them. So this isn't the only one. What would you do for your kids? Mine would cut each one and try it until they found them all. And we have done this. Except my pictures are usually bigger. And
Very.
would you mind passing my number? Do you have a question? I love this stuff. This is why I'm going to high school this year instead of teaching 6th grade. And I teach geometry. Okay. So you are certainly welcome to take this home, cut them out, build them. It would be a good exercise. I would suggest that you copy it first so that you can go back and go, what was the shape? Trust me. And my kids usually get 2 pieces. I have some extras. You're welcome to them. Okay, so moving on with the nets. If I took my isometric dot paper, oops, would that be a good thing to use to draw this picture?
No.
No, why? It's 2-dimensional. This is the 2-dimensional part that folds up and becomes the 3-dimensional piece. Can I count the edges? Let's just start with the vertices. Take yours and count the vertices. If you don't have it out, just count with somebody. Count the vertices, please.
Do you count each individual piece?
Ooh, interesting. I don't know. Count the vertices. 6 vertices? Is that all you see?
4, 5, 6.
If it's like this.
Okay.
Where,
But if you're renting this,
but now wait a minute,
then
there's
there's no.
Ah,
One,
good question.
there's one more line segments needed.
2, 3,
How many vertices did you get?
8.
8? Really? How many did you get? 6? How many did you get?
Line segments.
So does that, you're supposed to count that as a vertice? And what is a vertice? Point where 2 are, so you count it? Good. Anybody get more than 8? How many did you get? 14. How'd you get those?
For me, these are showing me line segments as well, and so I'm counting into the chunks of each of them.
So you counted each point, wherever they intersect.
Wherever two line segments met, whether I counted it.
Is that what you get for a cube? No. So, is this a good way to count vertices?
No.
No. Be careful because the kids will overlap. What I asked to do was exactly what you did. Good job. But I knew, some of y'all knew, that they were going to come back together and become the vertices of this. Okay, what about edges? Same thing? You're going to overlap on edges if you count each edge? Okay. What about faces?
No, faces,
No. Faces you can count. And all cubes have how many faces? So on this little paper, let me put mine up here. On this paper, one of the first things, and these were some of my students that weren't so bright, knew that wasn't it. Why?
Because it has more than 6 faces.
It's less than 6 faces, so it couldn't be right. So let's X it out. Okay, moving on. There's a lot more to do with these, and I want to finish up this lesson, and I'm going to finish it by giving you a puzzle. While I'm handing the puzzle out, if you would like to put your stuff away, we're done with all pieces. Oh, thank you. And this is a puzzle. You're welcome.
Ain't nothing going on with that.
You're welcome.
Should have 8 shapes with 8 nets.
Okay. Now, what I will ask right now is that there is absolutely no talking or discussing this problem with anybody else. Even if you don't even know where to start or what to do, keep reading it and try some ideas. You have room on the back to look at this. But I ask you not to talk to the people around you. And I'll tell you why. Oh, I'm sorry. What I have found with my students is this. Some of my best kids work together. They form study groups. They work with problems together. They check their work. If their work is wrong, they work together to find the answer. Sounds perfect. When we do classwork, they do the same thing. When they get a test, it's individual. They hit something, and they have no clue what to do. Because they have not figured out the process of going in and finding their mistakes. asking you, please, work by yourself, and then I will let you work with other people. You can use any of your papers you want to work on it, and you can write on this. Do y'all want one?
I'd like to see it.
You can't read that.
You know, I haven't visited my optometrist yet this month.
Okay, at this point, go ahead and talk in your groups. Talk with the people around you.
What exactly are you supposed to find?
That's a cylinder, that's it's gotta be this shape.
Alright, so while you are working on your puzzle, and I can see that a lot of you are like, huh? I'm going to read you a book. We've been reading the series, Circumference. If you haven't read these guys, these are awesome. This is called Circumference and the Sword of Cone. Of the Cone. And yeah, Amy just caught me. Let me get my glasses. If you have not read to your middle schoolers, you are missing a treat. Oh, my kids love it.
The series is called Circumference.
It's called Circumference, but there are so many books to read to them. I took one that was called And the Doorbell Rang. And the opening thing that we do in the year is we do a rubric. Because the kids really and truly, they've been given rubrics all their lives, but they really and truly do not know how to make them. Or how to do stuff with them. They don't know the difference between the 2 and the 3. I mean, they just look at it and go, I don't know. So I put chocolate chip cookies in front of them. Well, I start with the little 100-calorie chocolate chip cookies. And I say, yeah, we get cookies to eat today. But don't eat it yet. So they describe it. And then I bring out a generic chocolate chip. I usually go get a nasty, icky, cheapy generic. And I give them that. And we discuss the differences. So which one's better? This one would be better. And they can break, well, not yet. Then I get, my kids prefer the H-E-B brand chocolate chip to Chips Ahoy. So I bring those out. Now look at the difference. What's the difference between the 2 and the 3? And they talk about it. And we decide. And they start writing them down. And then I bring out one that I made by hand. And give them that with a glass of milk. And now, and I post this up on my board after we have filled it all out. And every time they go, I don't understand, look back at the cookie review. But at the end, I read this book. It's called The Doorbell Rang, the Grandma and Chocolate Chip Cookies. Amazing. They love it. They love it. Okay, so I'm going to read this to you, and this will be our final thing. For Seth, who soars on wings like an eagle, that's her son, I guess. One fine morning, Circumference, Lady Di of Amateur, and their son Radius sat eating breakfast in the King Arthur's castle. Suddenly the door flew open, and a young lady ran into the room. It was Vertex, Radius's best friend. I found out why King Arthur called us all here, Vertex explained. The kingdom wants to choose an heir, Vertex explained. 5 knights are competing for the honor. I'm one of them. You would make a fine king, Circumference said. That's right, agreed Radius. You helped the king make peace with the Euclideans last year. Yes, but now I have to solve the puzzle on this parchment, Vertex said. The king has hidden his sword, Excalibur. The knight who finds it will be the next king. So, Vertex unrolled the parchment. This is the only clue the king gave us. Look at these strange drawings, Lady Di remarked. They look like wooden tabletops. Let's go to the carpenters, agreed Radius. They know a lot about building tables. Vertex and Radius ran down to the courtyard. They saw the other knights trying to find Excalibur. One knight was carving solid shapes out of wood. Another knight was counting the edges of each stone in the castle. A third knight was inspecting the points of several swords. The last knight was looking through school books for a test on the number 2. I know a shortcut, said Radius. He led Vertex through the tunnel. This will take us under the courtyard to the carpenter's workshop. The tunnel was dimly lit, and scratching and squeaking came from the dark shadows. When they got to the workshop, Vertex showed the carpenters, Geo and Sim of Metri, the drawings on the parchment. Do you know what these are? Yes. These are drawings showing a solid shape flattened out. You can use them to make shapes with height, length, and width, added his brother Sim. I see, nodded Vertex. Let's try it, Radius. Vertex and Radius cut and folded the shapes. The parchment says the shapes will make 2. The shapes that make 2 will pass the test, said Vertex. This cube has 6 squares or faces, 8 corner points, and 12 edges, where the faces come together. How do you get a 2 from that? Let's look at the pyramid, said Radius. It has 5 faces, 5 points, and 8 edges. I don't see a 2 anywhere. Maybe we have to add the number of faces and the number of points, said Vertex. If we add the pyramid faces and the points, we get 10. 10 minus 8 edges is 2. Does it work for a cube too? Asked Radius. The cube's 6 faces plus its 8 points is 14. 14 minus the 12 edges is 2. I think you're on to something. Vertex and Radius finished making the shapes. There were cubes, pyramids, rectangular pyramids, triangular prisms, cylinders, and cones. Vertex counted the faces, the corner points, and the edges of each shape. He added the number of faces and points, and then subtracted the number of edges. The answer was 2 each time except for the cylinder and cone. And I know we didn't do that because of time, and I knew the book would explain it. Vertex unrolled the parchment and read again. The shapes that make 2 will pass the test, but one that does not must be your quest. The cylinder doesn't have any points, and the cone doesn't have any straight edges. They can't make 2 and will pass the test. Our next clue must be a cylinder or cone, he announced. Look at this. I made a model of the castle with the shapes. Here is the pyramid roof on top of the rectangular towers. The other towers are cylinders and they're cone-shaped with their cone-shaped roofs. Vertex looked at the model. Let's search for Excalibur in the round towers, since they are built in the shapes of cones and cylinders. Vertex and Radius climbed up and down the spiral staircase in each round tower. They looked under every trapdoor, in every suit of armor, and behind every tapestry. But there were no signs of Excalibur. Let's search from above. They went to the roof. Vertex had a commanding view of the castle courtyard. Look at the stones in the path, he said. Each of those round paving stones could be the bottom of a cone or cylinder. That path in the same direction as the tunnel that path is in the same direction as the tunnel we went through. Does everybody see what they're talking about? I don't know what you can see if I'm not projecting it well. Vertex and Radius returned to the tunnel. Sharp points jutted down from the ceiling. These points could be the tops of a cone, said Radius. We need to dig them up. Vertex and Radius waited until midnight, when the courtyard was empty. Vertex remembered the words of the parchment. 3 times as tall as his base is wide. The true king's future lies inside. If the base of the cone is its circular bottom, we need to measure the width of these paving stones. Vertex measured one of the stones. This cone is 14 inches across its base, he said. So it must have a height of 42 inches to be 3 times as tall, replied Radius. Vertex and Radius dug up the cone. It was 47 inches high. Oh no, said Radius, that's more than 3 times as tall. Let's try another one, suggested Vertex. He and Radius dug all night. They unearthed and measured many cones, but none was right. Some were too tall, while others were too short. They still had many cones to go when the full moon set and the day began to dawn. We'll never finish this, groaned Radius. We looked for clues in the tunnel and dug up lots of cones. Where else can we look? We've looked over the cones, under the cones, and on the cones. But what if Excalibur, Edgecalibur, is hidden inside a cone, suggested Vertex. Are any of them big enough? Excalibur is a sword, so it has to be about 48 inches long, about the length of this shovel. Vertex asked, will you go back down into the tunnel? Soon Vertex heard Radius's voice from below. I'm in the tunnel, but what am I looking for? Vertex placed the shovel in the nearest hole. Can you see any cones that are as long as the shovel? I see 4 cones that are about the same length, Radius answered. Excalibur could be hidden inside any one of these cones, Vertex said. But the cone we seek must be 3 times as tall as its base is wide. Excuse me, sorry. Turn that off. Reading the book. Reading the book. Almost done. I'm sorry? Whatever. Dr. Browning. Okay. Yeah. She doesn't employ me, so I can do that. Excalibur can be hidden inside one of these cones, but the cone we seek must be 3 times. Okay. 48 inches divided by 3 is 16 inches, said Vertex. He measured the bases of the 4 cones. All were more than 16 inches, but the last one was close. As the sun peeped over the horizon, Vertex started to dig. Radius ran back up to the courtyard. Vertex heaved and tugged on the stone. Finally, he pulled up a large cone. Vertex measured it. It was exactly 51 inches high, 3 times the 17 inches of its base. Vertex pried off the base of the cone and pulled out a gleaming sword. Excalibur is found, he exclaimed. As Vertex held up the sword aloft, everyone in the castle came running out. King Arthur said, you have solved my puzzle, Sir Vertex. Tell me how you used your wit and will to find Excalibur. Vertex bowed low. Sire, he said, I folded each of the diagrams on the parchment into a solid shape. Then for each solid, I added the number of faces to the number of points and subtracted the number of edges. The answer was always 2 until I got to the cylinder and the cone. So Radius and I searched parts of the castle, shaped like cones and cylinders. We found these cones buried in the courtyard. One of them was 3 times as tall as its base was wide. Excalibur was inside. Vertex knelt and held out the sword. King Arthur smiled. Sir Vertex, you have used your intelligence to earn the greatest honor that I can bestow. The king took Excalibur and tapped Vertex on each shoulder. I dub you Prince Vertex. When I can no longer rule, you shall be king. Rise now and greet your subjects in your hands. Their future is solid shape. The crowd cheered. Huh? It gets to it. Vertex said, I want to thank Circumference, Lady Di of Amateur, and Radius. They helped me measure up to the challenge. I hope they will be my new advisors when I am king. Vertex eventually did become a wise and thoughtful king, known to his people as Vertex, the line-hearted. To this day, the point at the heart of two or more lines is called a vertex. So, and then it goes through and tells you about oil. Ding, 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 bell ring. Don't forget all your stuff. I'm done. So, not time to leave.
No, I was like,
Yes.
where are we going?
What
But
to do?
What do you do?
What to do?
What
I
time is it?
hope, I really do hope that y'all have learned a little bit about some 3D geometry that you didn't know.
Well,
I
we're gonna
have
do lesson
extras
planning.
of the story and the book, and I have extras of the net. And I select the dot table. So thank you very much. I'll go on.
So we're gonna do lesson planning. Jen has some gags, your glance, and some scope and sequences from Jen and Zenita's school that you can use for reference or if it matches your grade level.
Northeast ISD. So, is that where you are too? You're at
I was
Northeast?
there.
And now you're,
Now they moved to high school.
right, but you're still with Northeast ISD.
Right. And I'm still with town.
You're supposed to present on Friday.
Will you take one of us around?
You're not done.
We're leaving the room. Yeah, we have break. It's all break time.
And then come back for the
I wasn't teacher. We'll be clever at 3:45, so you have from now until 3:45 to do lesson planning. I know that some of you, some of us got to work on it yesterday. Some of us are still working on our year at a glance, our scope and sequence. So you'll have this time to do your lesson planning. Dr. West is, Friday is going to, after you test, is going to, want you to be able to present your lessons. So some of you that have been here already, you know, maybe talk to the new participants about what that looks like and what she's going to, and I just wanna say that your lesson, even though we've given you time to plan on it, it's not gonna be perfect. And when Dr. West is, like Donna said the other day, questioning you about your lesson, she's not trying to be rude or ugly about it, she's just trying to make it better.
This is not a she does not do a teacher evaluation.
And
She really doesn't.
it's not gonna be graded, her hope is that you take this back to your classroom and use it. That you're not just spinning your wheels during this time, doing something that you're never gonna use again. So think about that and really think about, you know, what you wanna do in your lesson and how you're gonna present that information. And don't feel badly if you get up there and she's like, because it's hard. It is hard to plan a very thoughtful, integrated lesson. If it were easy, we would all be doing it and we wouldn't need to come to this. So, yes ma'am.
What if we're not in that far?
It's okay. She's gonna want you to present whatever you have.
Can you show off my scope and sequence?
I already got this. If you think, well, that's right, I needed to make a copy of it today. But she's gonna wanna see a lesson. She's gonna wanna see at least, like, this is my idea, this is the tech, or teeth that I'm working on, and this is the support for that teeth. She's gonna wanna see it. Teresa? I'm here. Do you need some help?
We don't use teeth. We don't have
Okay, so.
I just.
What have you chosen?
They said to stop.
We
Trying to plan, listen, and
will discuss the lesson
do a scope first.
with the rest of the group. And Dr. West will give feedback on the lesson.
Yeah, and that's what I did at first. And they're like, no, just stop and do this. And I was like, no, you want this? Like, stop trying.
Well, great. The format has already been given to us. You don't know yet? On Dropbox.
I know it was, and you were from pre-K to ninth grade. Now it's been shrunk down to anywhere from pre-K to mostly fifth grade.
We're going to. Okay, so lesson planning is. have time on Friday.
So you have to take integrated lessons, because you probably have 2 grades.
And that's fine.
We don't do lessons, we never go. We just get curriculum and our tier teacher does.
And do you have that? Because I'll be glad to help you.
It's been a mess. It's fun, but
Well, at least get your opening ready. What are you teaching?
What is
If I have someone else that's off presenting them a whole different ballgame, we do it.
Well, I mean, like, let's say, she has a, she's talking, but then the other people are still talking, like,